Dear students, I am Mr. G. Pujari, working as an assistant professor in Sharon Stop Technology College of Engineering. Today we are going to learn about the casting. Casting is one of the process which is used for the manufacturing processes. So today we are going to learn about the casting processes. So dear students, casting is a exploit the fluidity of metal in liquid state as it takes shape and liquefies in a mold. So it's the primary manufacturing process. So casting process is nothing but we are manufacturing the product, we are going to prepare a mold, and then we are preparing the liquid metal, and we are going to pour the liquid metal into the mold. By this way, we are getting the casting process. So, dear students, when we discuss, there are so many kinds of steps preparing the casting. Casting is one of the this is a like a foundry process. So, in a foundry, there are a lot of steps are required to be prepared when you want to manufacture any kind of product. So, steps to be followed for casting operations are: first of all, you require to making a mold cavity. Means what type of part you want to create. For such parts, first of all, you require to prepare a pattern, and by using this pattern, we require to create a mold cavity. And in this mold cavity, we are going to pour a liquid metal. So first important thing here is we require to prepare a one kind of mold cavity. So mold cavity is nothing but it is a hollow part inside your mold. So whatever the liquid metal we are going to prepare, this liquid metal we are going to pour inside this cavity through the pouring basin. So the first thing that is where we require to prepare a making a mold cavity is the first step of the casting operation. Second, then liquefy or melt the material by properly heating it in a suitable furnace. So what type of materials you want to cast? That material suitably we require to melt. So we are having some furnaces. It can be electric furnace, it can be induction furnace. In such a furnaces, what we are going to do, we are going to melt the material. So when you are going to melt the material, it is going to convert it into liquid form. Okay, so that liquid form, when material is in a liquid state, that within that period we require to take this liquid metal and we require to pour into the mold cavity. So that's second method, or we can say second step is very much important in this, that we require to maintain the liquidity of the metal. So it must be in a flowable condition. If it is become a solid, we cannot able to pour inside the cavity. So that's why when we are going to convert this solid material into liquid metal, within the same time we require to pour into the cavity. Then third one is whatever once you have completed the melt material by properly heating in suitable furnaces, then third process or third step required to liquid molten metal is poured into a prepared mold cavity. So whatever the mold cavity we have prepared, in this we require to pour this molten metal. Then next step is very much important to allow to solidify. So we require to wait. So whatever the molten metal we have poured inside the cavity, it required some time on the basis of the melting temperature of that material. It will take some time for solidify. Okay, so solidification till then we require to wait. So allowed to solidify the stay allowed to solidify. It is the next step of this process. Then after this product is taken out of the mold cavity. So once our product is become solid, it is become a cooled, then we are going to cut the mold, we are going to break the mold, and from this mold we are going to take out our product. Okay, so after this we require to trim the part because some kind of excessive material is going to add over our part. So whatever the excessive material is added on our part, that we are going to trim, and we are going to again we require to do some kind of machining. That machining allowances are already we have considered while we are preparing the mold. So that we are going to give some shape, by using some VMC machine, by using some CNC machine, or by our conventional method by lathe. So, dear students, so whatever the process we have completed, for these processes, we are having some kind of advantage, we are having some kind of disadvantage. So, first of all, we are going to see the advantage of this casting process. So first advantage is molten material can flow into very small sections so that intricate shape can be made by this process. So whatever the molten metal, it is in a liquid form. Because of that, it can be goes into intricate shapes of the mold. So intricate shapes means whatever the small sections here, because of the liquidity, because of the flowability, this metal can be goes inside the intricate shapes. Okay, so that's is the most important here. So whatever the intricate shapes are present inside the mold cavity, the flowable liquid metal is going inside that cavity. Then, as a result, many other operations such as machining, forging, and welding can be minimized. So, because of the we are casting or we are preparing the parts from the casting, here lot of machining is not required. When we are going by conventional process by on a lathe machine or VMC, CNC machine, lot of machining is required. Lot of material is going to waste by removing the material. But because of the casting process, very less material we require to machine, does not require much forging and does not require that's welding. So these are the number of processes that we are going to minimize. Here again the possible to cast both ferrous and non-ferrous materials. One of the again important thing is not only ferrous materials we are going to cast, but also non-ferrous materials are also we can be cast. So whatever the number of components, those are components we can be able to cast, and those are non-ferrous that are also we can be able to cast. So this is the very much advantage of this process. So again, the tools are very simple and uh, some tools are very simple and some tools are expensive. Okay, so on the basis of that we can prepare the mold and we can be able to prepare the casting and small lot production and whatever we discussed that it is expensive. Okay, and this casting process is also useful for the small lot production. So means that it is not only we required to produce in a large quantity. If we want in a small quantity, it is also can be possible to produce in a lot in a very less quantity. So here also possible weight reduction in design that can be possible. No directional property. There are certain parts like turbine blades made from metals and alloys that can only be processed this way. So here turbine blades are only making by the way of casting. So they can be, we are going to prepare a mold and whatever the design of these turbine blades, by using this turbine blade design, we are going to prepare a mold and in this material, we are going to melt the material by which materials we want to prepare these turbine blades and then we are going to pour this molten metal inside this cavity. So like this, you can be able to prepare a turbine blades. So turbine blades are fully casting plus last machining. So small amount of machining allowance we are going to keep inside the mold. So whatever the part you have prepared, these parts are after that we are going to machine. And by machining, at the end we are going to control the dimension of your turbine blades. Then again, size and weight of the product is not limitation for the casting process. Means that any kind of size, any kind of shape, length, width, height, you can be able to prepare by this casting process. The weight is also not your limitation for this casting processes. So as like this, when there is a having advantages for every processes, so again there is a having some kind of limitation for these casting processes. So first limitation is accuracy and surface finish are not very good for final application. So as I said earlier, we require to control the dimension by doing some kind of machining operation like lathe operation or some kind of VMC operation or some kind of CNC operation by which you can be able to control the dimension of your end product. So accuracy and surface finish, that is not you will get as a machine. So whatever the machining accuracy or surface finish you are getting when we are going to complete the job on VMC, CNC or lathe, that kind of accuracy you will not get. Okay, so always we require to keep open tolerances for such a casting parts. Second, difficult to remove defects due to presence of moisture. Sometimes some moisture or sometimes some gases are going to lock inside your parts. So because of this, some kind of defects are going to add inside the parts. If suppose moisture is there, again part gets some defects. Suppose some gases are going to trap inside your part, then it is going to create some blowholes inside the part. So because of that, that is going to create a cavity inside your part. Then metal casting is a labor intensive process. It means that for preparation of mold, then pouring the metal, then melting the metal, then pouring this molten metal inside the mold, it requires some kind of labors. So whatever the casting operation you are doing, so if you have not done automation, then you require to do lot of things by manually, or we can say by using or getting the help from the labors. So also this is one of the limitation that metal casting is a labor intensive process. So dear friends, today we have seen or today we have learned about the what is mean by casting process and the casting process, how many steps are there to do the casting process, and then we have seen the what is the advantage of the casting process and limitation of the casting process. So I'm very thankful, dear students, for listening this carefully. Again, in next video, we can learn about the many more other activities about the casting. Thank you. Thank you very much.